In our last video, we had discussed about basics of ARM processor platform. Today we are going to experiment on Nucleo G474 development board. As everybody does, we can start with the basic blink LED program. In Nucleo G474 board, there are total 4 LEDs, but we can control only one LED using our program. This LED has been connected to pin 5 of port A. In this video, we will see how to make the LED blink using 2 lines of code. In order to write and download our code into the microcontroller, we need a software called Integrator Development Environment. Simply, we can call them IDE. For STM32 devices, we can use STM32 Cube IDE. There are other IDEs are also available such as IAR Workbench, Atomic True Studio, Keel, etc. Advantages of STM32 Cube IDE are it is a free software and it is coming with a CubeMX software, which is a GUI tool to easily configure our pins and ports in the microcontroller. For a beginner, I recommend using Cube IDE software. We can download Cube IDE from ST website itself. So go to their website. You can see different packages available for different operating systems. Since I am using Windows, I will click on Get Latest button here. If you are not registered, they will ask for the user details. You can give your name, mail ID, etc. and you will be able to download the software. I have already installed software in my PC. Now we can launch Cube IDE. First we need to set up a workspace location. All the projects we are creating will be stored in this workspace. So I am creating one folder here. To avoid asking this every time, I am checking this box. This will be the start screen. We are starting a new project using the CubeMX GUI. So we can click here. Now we have to select our device. So we have a development board with us and not a microcontroller. So click on board selector tab here. Now we can type the board model here. Yes, we have got our board. Now click next. Now add a project name here and keep all these default settings as it is. So keep next and then finish. Yes, now we have to click yes and again yes. In this new window, there are two parts. On the left sidebar, you can see all the sections of the microcontroller. If we click on A to Z, we can see each of the MCU component in detail. We will see each of these components in our upcoming videos. In the right panel, we can see a big picture of our microcontroller. This is not the development board, but it is the pinout of the microcontroller. For example, we know our LED is connected to pin 5 of port A. So go here and select PA5. PA5 means port A pin 5, okay? And we can see all the configure options for this pin. We can make this pin an output pin or an input pin like that. Now we can configure the microcontroller according to our requirement. For blinking the LED, we need to configure our pin as an output pin. Go to System Core here and select GPIO. We can see PA5 pin here. Now we can configure these parameters for this pin. GPIO output level low means initially the pin will be having 0 voltage. Rest of the things you can keep the same as you are seeing in the screen. So now we have finished configuring the pins. Now we have to configure the clock. So click on this next tab. For the MCU operation, it needs a clock source. There are mainly 4 clock sources. The maximum clock frequency we can get is 170 MHz and that is provided by PLL source. PLL means phased locked low. We will see about the clocks in detail in upcoming sessions. So here we are selecting maximum clock frequency. Next is code generation. For the configuration we have made in the previous tabs, this tool will generate the code by its own. That is the beauty of this software. You can keep all the settings you can see in this window. In order to generate the code, go here and click on Save button. Okay, perfect. You can see all the source files here. If you want to see the main.c, you can expand these folders. In main.c, you can see this ready-made code. For our requirement, we have to add only just 2 lines of code. HL is a special application library function. All the GPIO related functions will be starting with HL_GPIO prefix. You don't need to type all the function by your own. Just press Ctrl plus space and it will show us some suggestions. Toggle pin is used to toggle the state of the pin. For example, if the pin voltage is high, then if we call this function, it will reset the pin state to low. Now we will see its arguments. The first argument is port name. So here we have to type GPIO A. It means that is representing port A. Next argument is pin number. So here we can type GPIO underscore pin underscore 5. Don't worry about all these terminologies. These are all HL macro variables and you will get used to these once you progress in your development. HL delay is used to add some delay to execute next instruction. The value inside this bracket should be in millisecond. In our case we are adding 1000. It means it will give 1 second delay. Since this is inside a while loop, these two lines will be executing infinitely until we power off the microcontroller. Now we can build our program. So 0 errors and 0 warnings. Now click on the debug button. So we have a new window. Don't change anything here. Keep the default values. Now click on OK button. The starting of the program is starting of main. The debugger is waiting for our command. So we can start the execution by clicking on the play button. Now we see the board. You can see the green LED blinking there in every 1 second. If we click on the pause button, we can see current location of the program. So it is inside a driver function. If we click on our application function main, we will see the location here. So I am adding a breakpoint here by double clicking on this side area. Now we can break the execution every time we click on the play button. Meanwhile, we will notice the LED also. So I am clicking the play button. Now LED is off. Again I am clicking the play button. Now LED is on. So this is how it is toggling. The delay function will not have real-time meaning if you use the breakpoints. Now we can reduce the delay to 500 millisecond and we will see. We will debug once again. By checking this, it will automatically save the file and build. Now you can see blinking is faster. So I hope everyone has liked this demo. Please inform me in comments if I need to change my way of presentation or to add anything more in context for better understandability. So we will see again in our next video. Thank you for watching. Bye.